We're at gotomath.com, pulling our hair out. We're at Optimization Problems, and okay, I guess that's the last one for right now. 6-2. If I can get it to come up. We got an open box to be constructed from a rectangular piece of material that has a width and length of 29 inches and 12 inches respectively. Width and length of 20 respectively means, right, width is 29 inches, length is 12 inches. Squares are to be cut from each corner, turned up. Find the dimensions that gives a maximum volume. So 29 by 12. We want to maximize the volume. So this is just like 6-1, except it's not a square piece of material. It's not a square piece of material. So we want to maximize the volume, right? So we have a rectangular piece actually. Whoa, it's not exactly rectangular, but anyway. This is, we'll let this side be 29 and this side shall be 12, okay? Now of course squares are to be cut from each corner. We're going to attempt to draw some squares. And that means that this is x and this is x right here, right? Okay. And let's just sketch out maybe down here somewhere, I don't know. When we cut out the squares, fold it up. Okay, so the height is x, right? So we cut this out and then we fold up. Fold this piece up right here. As you can see, right, this should be x. This would be the height. Now this side right here, since the entire side is 29 inches, question is, what is this distance here, which should actually be, let's say, the width of the box. For example, this is going to be 29 minus 2x, right? And then this side over here would be 12 minus 2x. 12 minus, okay, that's supposed to be a 2 there. 12 minus 2x. So the actual volume is going to be x times 29 minus 2x, and then we'd have 12 minus 2x, okay? And we're trying to maximize volume, so that means we need to take the derivative of this thing, set it equal to 0, and so forth. Now, I'm going to let you go ahead and multiply all this stuff out, and then I'll tell you what it should be. Okay, so we just got to save a little bit of time here. But when you expand this out, in other words, multiply this x inside, then do the FOIL thing, multiply both those together, we should be getting, we call that expanding, 4x cubed minus 82x plus 348x. Alright? Then what we're going to do is take the derivative. So we have 12x squared minus, what did I leave off here? Left a square off right there. Boy, that could be a problem. That's going to be 164, right? 164. And then plus 348. About put a 0 there. Let's see, 164, yeah. Okay. So that would be the derivative. And then, of course, we want to set this equal to 0. Minus 164x plus 348, and solve for x in this problem. Alright, man, I guess you need to use the quadratic formula. Do we remember what that is? It's a if this were A, B, and C, this would be B plus or minus square root of B squared minus 4AC over 2A, I believe. Anyway, you'll have to use the quadratic formula on that. Okay? And it's not that bad. But I will go ahead and tell you that X is going to be approximately, you're going to get two solutions here. And one of them, you're going to get 2.6269, yada, yada, yada. Bunch of stuff out here. And then the other one you're going to end up getting is X is equal to 11.040, some other stuff. Well, obviously you can't use this one, because if this were 11 and that was 11, where would 12 be, right? So, forget it. Okay, you can't use it. You can only use this one here. Okay, so can't use that. So you'll want to use this. Try to use the exact value. And then, so to get your dimensions, right, you're going to take this X and plug it in here, right? That gives you, you can define length, width, whichever one, and then plug this number into here, right? And this, so I can't remember, but should have been defined, I guess. Oh, actually it wasn't the problem, wasn't it? I forget. So it was a width and length. This was the width, this was the length. Okay. There you go. Oh, Lord. The width is the 29 inches. So this was the width. Actually, I did have that right. That's the width, that's the length. All right. And of course, this is the height right here. I don't know if I've even got that on here. But anyways, you can see I went ahead and hit the answer there. So we got the width, okay, was the 23.746 inches. We rounded 3 decimal places. And then the length, and for some reason I don't have the height written in here, and I don't know why, but I probably need to, which is X, right? I need to check that out. I'm going to check this volume out here real quick. 23.746 times 6.746, just to make sure everything's good on that, times 2.6, 2 point, making sure 420.82, yeah. Okay, so you'll want to use the exact values, right, to probably get that volume. I don't know, work with that. Anyway, you got the idea. Okay. All right, well, come on by Go To Math, practice that. Those are typical problems you normally see on a test, homework, quiz, or maybe you just want to work them out for fun, right? Okay, and maybe I'll see you there. Bye.